Um, okay. Hey everyone. So, just got started with the live stream. I had a couple other calls, so I got delayed with stuff. So yeah, today's really just a chance to do um some live coding for Oktoberfest, or Hacktoberfest as it's called. And yeah, I really want to show people how they can contribute to our repository in particular, which is Flow Forecast. For those unfamiliar, I'll just go very briefly over it because you can probably find a lot of the information in other videos, but this is essentially an all-purpose deep learning for time series uh, repository, and the goal is to make it really easy to leverage the latest state-of-the-art models for time series in a kind of easy to use framework, and also be able to very easily sweep over a lot of different hyperparameters and even pre-train your models on different data sets. So almost, I guess, kind of think of it as a Hugging Face of time series is the idea. Though we're not quite there yet, which is why we are really trying to get some stuff done over the next few months. So yeah, that said, I'm just going to go through and jump right into our kind of live coding session. Yeah, as I said, first we're just gonna initially just go over some current PRs and kind of what I look for in PRs, and then we'll potentially merge those. Then I'm going to go on to adding kind of a new model. So let me just check and make sure everything's on. Yeah. Okay. Yeah, I think everything's good. Yeah, I'll just. Oh yeah, I didn't turn video on. All right. So yeah, so first, what we want to do is we'll just look at. This is an example pull request. The first thing you'll notice kind of when working on a repository, we have automated checks from Circle CI. So basically these checks are just to make sure that the code passes its unit tests, and in general we require unit tests for all of our stuff. So, oh yeah, I don't think that's the actual one. So for instance, here's an example, recent kind of example. We also have CodeCove, which is a coverage report, which shows how much coverage there is on the repository. Though actually, I found CodeCove is working kind of a little buggy, so I'm not sure actually how accurate it is. Normally, for most PRs, the PR should in general be linked to a specific issue in our kind of issue backlog. But some of these were already discussed. So, but yeah, in general, when you open a PR, which I'll show in a bit, you'll tie it to a specific issue that you're working on. And yeah, particularly when you're doing open source and you want to do an issue, you probably should just comment and then self-assign it to yourself. I'm pretty sure people outside of our org can self-assign, but I haven't looked. So in any case, this one is actually ready, I think, so for merging. So right here, actually, we can see, I think, 2 of the unit tests failed, and there's actually a merge conflict because I had to actually add some stuff to it. So we're just going to really quickly resolve that merge conflict and then merge this. By the way, this PR is to, in general, add probabilistic DNNs in PyTorch, so instead of just outputting one thing, outputting a distribution. So this is fine. This is a pretty easy fix. I don't think there's any difference here. That's hopefully the only thing. So yeah, this is essentially our config file for our Circle CI tests. I think that can be marked as resolved. What's that? I don't know why that's there. And then we just scroll down through it. I know Code Factor does look at some of this, but so this is the primary stuff. We'll just commit that. I think that should fix all the errors in this specific PR. So we'll just, while we're waiting for that to run, we'll start working on the other issue. So, and this we will do kind of by the book, so to speak. So just quickly, we'll go to this transformer bottleneck paper. So this is actually a code I've had for a while, and I've wanted to add to the repository, but I haven't had time to do it. This was a paper at last year's NeurIPS conference. And it was pretty good, but the code has actually been somewhat complex, so I haven't fully added it yet. So yeah, that's what I'm aiming to hopefully do today. So yeah, that was, so yeah, in general, I already created a branch for this a while ago. So I'm just gonna check out this branch, and actually I'll open that PR now, because I want to open that PR because I just updated, and we will be updating master, so I'm going to be having to update this branch a lot. So I'm just going to create this pull request. Here. And then we really will just kind of link this to the issue. So that way I know what this pull request is doing. So it's now linked to the issue. It's going to say it's out of date with master. So I'm just going to update that in. So so that's just going to update it. So far I don't think there's anything on it. Let's see. Files changed. So yeah, there isn't much difference here, but what we're going to do is now actually make this work. Okay, so yeah, we'll dive into this. So I think we can pull this again just to get the latest. Yeah, stash changes. Okay, so we'll throw this up. GitHub. Pre-processing transformer XL. So here we go. So yeah, this is just essentially most of the code that was copied from their paper directly. They have all these things. The outer class they kind of use is this decoder transformer. So we're gonna refactor this to work with our stuff. So if you worked with Forecast before, you know the core of our stuff actually shouldn't be throwing. We get things like we don't do args directly. Everything is will be passed as kind of the JSON stuff originally. So we're gonna first remove. Well, I don't know which we'll do first. First, we actually have to look at what's in args. So and again, why we're doing this way is because we're making it compatible with our framework, which also makes it compatible with all of our hyperparameter searches and neural architecture searches. So I think that should probably just be a separate parameter that we should set to none initially. can just do sparse then. Sparse. So it looks like there's a sub-length here. So I think that's a parameter we're going to have to include either way. So yeah, it looks like that's there. I was going to say that's following a default. And we'll probably have to go back to the original code a couple times to see what values in general they pass in for these. We don't need this. Device is determined in a different place for us. So, torch distributions, copy. All this is fine. Ideally, particularly if we had this code somewhere else, we wouldn't reuse it. But we'll just do that for now. Let's see args. Okay. So there are two. It looks like there are two different dropouts. So we'll get rid of args again, which is going to raise that error. We'll put this in here. So that looks like some dropout. We can make these default values so people don't necessarily have to supply them in the config. But that's kind of the idea. Sublength, row mask. Okay. So this is classic. Looks like self-attention, pretty standard self-attention. Okay, let's go back to that transformer decoder. Transformer model. Decoder transformer. So again, we're not going to be using args. So yeah, we'll actually just work probably from here up. So so yeah, again, what we're doing right now is we're just removing kind of these residuals that were probably associated with command line passing, and instead replacing it with proper argument passing. Okay. In the meantime, we can look back at that PR and see if the new stuff passed. It looks like it's still running, but it looks like probably our fixes will pass, in which case I'll merge it in a second. Yeah, so we can come back to that when this passes. So to device. So device is, I gotta remember how exactly, oh, so they're actually doing device there. Okay. Yeah, I actually wouldn't have device computed up here then. I know we removed that like a second ago. Let's see if we could actually just get that one back. But yeah, I'd prefer to that be a property of the model rather than just up there. Let's just look at where they use the device thing. Okay, so this should just be like, I feel like this should just be here, rather than as kind of a global variable. And this will just be then self.device. Okay, so now what we need to do is, so this is then becomes initializes the transformer model as we see. and that's basically what the args is. So input dim, so this is going to be equivalent to what I'll show you one of our normal models quickly. For our normal models, we have number of time series, the hidden size, and then all these other optional parameters. And then we have generally also something like sequence length, or forecast history. So I'm just trying to translate this to our common kind of parameter naming language. But it's hard because they don't have like doc strings or anything in their stuff. So yeah, this initial pass input dim is definitely equal to n time series for what we have, I believe. So n time series. So yeah, I mean, part of our idea is that like all models should have essentially roughly the same parameters when they can be common. Obviously, some models will always have custom parameters, but we want to have just as few changes to configs as possible, so we standardize essentially all the names for stuff like that. Okay, so what did I just actually input? It was something like input dim in time series. So again, this is our thing that we replace it with. Just replace that quickly. What's this saying? Missing white space around operator. Okay, that's fine. We can just actually, so n time series is just essentially what it's always going to be, and people should know that, but we will put the doc string. This is just going to be the same for this. And really, actually, I've been looking to do a bit nicer format for these. So we will do the args thing. In head, this is probably an integer. Oh yeah, these should also be type hinted. By the way, that's another thing we do with our repository. Everything is type hinted. So, missing white space. Because yeah, it just adds a lot of clarity. So number of heads. So I'm guessing, I'm not sure yet, but this is probably the number of heads. Well, it's pretty self-explanatory. The number of heads in the multi-head attention mechanism. That's what I'm probably like 90% sure it is. I'm not exactly sure what sequence number is. We're gonna have to probably look at their code in a second to determine what that actually is. Layer number, window length. Window length, I'm guessing, is roughly comparable to the forecast history, which is the number of historical steps we pass in. Trailing whites. What? Trailing. I don't see any trailing white space. But yeah, so actually that should be here too. Yeah, I discovered this should really be in all of our doc strings. So this is I'm pretty sure for now I'm just gonna put like a question mark here. Obviously when I revise this, which I probably will in a second, I'll change it. But this is just kind of my own way of documenting what my assumptions. So again, transformer model. It's essentially saying we don't have all this stuff. There's no dropout, there's no scale attention, there's no queue length. And so again, all these we're going to add as parameters here. Some of them we can specify default values for. But yeah, the idea is just that everything will be passed from the configuration file instead of like throwing it in from command line arguments. So yeah, on that note, transformer model. Seek number. So I think seek number is a new thing they have. I think it's like every Actually, I still don't really know what seed number is. What's this args dict? This is, yeah, a good example too of why you can really use type hints and stuff like that, just so that people can see it. Yeah, so this is good. They get rid of all the arg stuff. As people know, I don't like command line arguments and just calling args parse. I explained that in like my reproducibility tutorial, but it doesn't really actually help track things. So args, we could do that, and then so again we just have to update since we're removing args. So yeah, we can do just sublength. Sparse, those could be sparse, tension, p drop. Yeah, so likewise we'll just supply these here. Sparse, we'll do it to none, and then so sublength, sparse, tension p drop. Yeah. Okay, so so yeah, again, we're just supplying these as parameters now. This will all make sense in a second. So attention, and then we have just stuff like attention.pdrop. What is it? Pdrop. The other thing, yeah, actually we could do to clean this up is, to clean this up so we don't have to keep passing all these, we can do something like, I think sublength is going to be required either way, but for these last three, like, we could have, like, additional, like, just call it additional params or something. That way we'll, like, and this will actually be a dict. I don't know if typing's imported, but and then we'll just pass this dict of kind of params as keywords. Undefined name dict. Okay, so from typing, so we're just gonna do from typing. Yeah, because it doesn't make sense to keep typing all that crap out. Missing white space. Okay, so this is a block. These would be useful with type hints too, definitely. This looks like to be, yeah, just a standard block though. Block. So, so yeah, it looks like they actually do something maybe similar with the args dict though, I'm not sure. Though if it is, I don't really like the name of it. So again, I'm going to also alter these to the actual right thing soon. So, but yeah, so args dict, yeah, we'll just delete that for now. And yeah, as I said, we'll scale attention. Okay, so scale looks like it equals that, Q length. Okay, so yeah, we could do some of these. So block args. Oh wait, there's still args here. I need to get rid of that. So yeah, we'll just do like additional param. And then this will also be passed like maybe like an additional params that will also be a dict. I'm not adding type hints for the other stuff right now because I actually don't know what type it is without probably looking back at some of their code. Oh, this is too long. Yeah, this is a pretty long line. Self input dim forecast history. Oh wait. So yeah, that would be n times series. Just have that standard and head sequence number layer embed. So yeah. Yeah, as I said, just right now refactoring some of this stuff. Input dim. And yeah, we could try to write a unit test in a bit. I'm not going to update that right now, though. Dropout, we know, is basically usually going to be, what is it, like a float or something? I think it's going to be a float, usually. Okay, this is, yeah, I'm not making this line shorter. Yeah, so just replacing this. And that way we always know essentially what n time series are if you're familiar with our framework, so we don't have like a lot of different things. Okay, so want a sub length. Okay, so we could do I think we have to add that here though. So yeah, we're once again getting really long lines. Oh yeah. What? Yeah, that's what it should be. Not spelling it well. What? I just said that's what it is. Oh, crap. Stupid shit. What? Why isn't this? We're passing this. Okay, so it's basically too long. Again, yeah, and I don't know if I really like how long it is either. So what we could do, if these, I'm not gonna do too much. Yeah, for now I'm just gonna break this up. There's probably a neater way to pass these. But I'm not going to do it right now. Trailing white space. Doesn't like the trailing white space. I'm not gonna add all the type hints right now because, well, I don't know what a lot of the types are. But I will get to that in a sec. So. What? Oh, crap. It should be spelling. Okay, so that should be correct now. Okay, so that's kind of some of the major initial refactors. Yeah, let's actually, yeah, refactor a bit more now, so. Actually, now I'm going to go open up some of the original code for this, if I can find it. Oh yeah, so here's on the original code that was sent to me. essentially a zip file. So I think some of these scripts should tell us what some of this stuff is, because it's what essentially their initial params were. So n head is equal to 8. That makes sense. This is weird because this apparently actually appears to be a string. It's queue length stuff. Oh, number of layers. Number of layers. Where's number of layers front end? Does number of layers just go into layers? Okay, yeah. This should actually be number of layers. I'd keep this as this. Why isn't that appearing in red? I want that to appear in red. So yeah, that's basically the number of transformer blocks. So yeah, for a layer we can just do we now know this. So I am going to change that to number of layers too. So this is going to be an int. Oh yeah, this will be an int. Is that too long now? Oh wait, no, that's not too long. So number of layers again. So it's essentially just the number of transformer blocks is what I think it is. Because yeah, they're essentially they loop through. And yeah, this is what a block is. So yeah, it's essentially just the number of transformer blocks. So we'll just add that. Dropout. So dropout. So these would all be like probably what happened with this arg stuff we were decoupling. So yeah, we'll just remove the args and then we'll do. Oh wait. Do we still do anything with args here? Wait, no, I don't think I even pass it. So I'm just gonna get rid of this. That's still gonna be red. So window length, number of embeddings. Okay, let me just make sure I get the doc string right for this. Or I mean the actual parameter passing order. Because when you don't get it right, this will cause probably like infinite number of headaches. So again, this looks right. N times series, n heads, sequence number, sub length. That's where it varies. Sub length. So I think we need that as a param too. Sub length. Number of layers. Yeah, that's right. Embed. Window length. So this should be lining up now. So yeah, that's good. So yeah, then we just add these here. Dropout should probably be a float. Is that what it is in Python? I don't think it's a decimal, but yeah, it's just a float in Python. The line is already too long. So yeah. What was I gonna do? Oh, oops. Actually, I'm gonna just architect some of this in. So we had n head, sequence number, sub length. And as I understand what these are, I'll do something. Well, I'll put them in the right way. Yeah, so that one we already had. Of course, my linter isn't gonna like this. Num layer and embed. Oh yeah, and embed. Does anyone else find it weird? They're just basically like substituting out one letter. I don't know. I won't change it now though. Window length. Okay, yeah, and that's where we get to that, and then we would have dropout here. Dropout. And this would just be like, I think this is a specific type of dropout too, so. Oh yeah, we also need that additional params. This will just be a dict. And that's now way too long, but okay, be quiet and embed. Yeah, we'll fill those in a bit. So yeah, this is just, what's dropout go to? I think dropout just goes to the dropout, because yeah, I think there are multiple dropouts, so I'm just being careful to call which one which. Dropout. So yeah, this looks like this is the dropout for the embedding, so and then we'll just fill in that, what was it, window length, or yeah, a number of layers. Okay, so we're back to that good stuff. The linter is still annoyed. We'll break this up somehow. Missing white space. It doesn't like that. Okay. So we're still obviously fixing all this stuff up. So yeah, now we can just do dropout, scale attention. Scale attention on. Yeah, we'll literally just add all these, I guess. QN, and then additional params. It's gonna say we don't have those. And that, of course, line is also very long. So, yeah, I guess we can just do something like QN. So what was QN here? QN was actually, that should be a string. That's odd, very odd. It's a number, but they're encoding it as a string. Query key self.qn. But I think this, like, maybe it's actually an int. I don't know. I think it's basically an int. And it might just automatically get converted, though. I don't know why they do that, because no, they're like purposely encoding it. I don't know. I don't know why they're doing that. Because then QN, it looks like QN goes. They're definitely using it like they're definitely using it like basically an int. I'm gonna say for now it's an int, and we'll see if like when we actually pass it an int, it raises some weird error. Okay, I still don't have the scale attention. Trailing white space, doesn't like the trailing white space. Continuation line over indented. Okay, so that's basically correct, I think. So let's see what the scale attend. Oh, that's a boolean, it looks like. We'll do bool. Oh no, it's gonna say it's too long. Oh wait. Okay. Yeah, if it does start to say that, we can just throw it. So yeah, let's look at some. Oh crap. But yeah, I don't get why they specifically do this one with that, but not the others. It doesn't really make sense. Oh, I think this is then the actual stuff. Do we have the main file? Sync. Oh yeah, here's main. Layer. Layer, yeah. Yeah, that's basically what we sought there. QN. Yeah, QN is definitely an integer. It's definitely an integer. It's definitely an integer. Okay, so that's definitely an integer. Scale attention is a bool. Is there, wait, what about sublength? Sublength. Sublength of the sparse attention. Okay. Okay, so I'm just going to, did I commit some of this? Oh yeah, I did. Yeah, I'll save this. I'll do refactoring. So this will actually pass probably, which it shouldn't. But yeah, I just commit frequently to have a record in case I need to roll back. Now I think this is all good. So all the checks had passed. I'm just going to quickly do a review of this. As you can see here, I already reviewed it once and it looked good. But I'm just going to briefly review it again. So where do I review? Reviewers. Okay. Wait, I want to start a new review though. I'm pretty sure I'm going to approve this, but I'm just going to look through quickly. I think she fixed this, right? Or she put it in a different PR. Is that a separate one? Either way, I think it's good for now, so I'm just going to resolve that. Decoder, evaluation, decoder params is not none. Okay, yeah. Yeah, so she did fix it, like here, I think, actually. That's just a random question. This looks good. So yeah, in general, when you add loss functions, you add them in the exact same way, like here. We'll get to that though. Actually, I'll show that later too. NumPy to tvar, probabilistic. Okay, this looks good. Okay, that looks fine. that's if probabilistic. So yeah, she basically just added an else here, which for the probabilistic models, because they have a slightly different structure. Okay, so tests are passing. Inverse scale if probabilistic. She rewrite all the scaling? I'm confused about that. Because you'd think you could just reuse a lot of the scaling code. If probabilistic. Oh yeah, I think it's because it has to be slightly different because that's outputting a distribution. I believe. Probabilistic equals false. Okay, so it's automatically, yeah, that's good, that's what we want. NumPy to tvar, she just added this there, so I'll check that off. That would look good. That looks good. Okay, so yeah, it has a different. Okay, yeah. That looks good. Okay, so this was some of the stuff I was finding confusing, where she modified the training loop. So she imports this. I'm pretty sure though if she actually modified the training loop in a bad way, the unit test would pick up on it. Simple decode. Okay. Okay, yeah, that makes sense. Oh wait, did she remove something though for that? Because like, I forget, like, or is that like in compute validation? Oh yeah, so, okay, I gotta check this out quicker because that's actually complicated. I think that's what I was looking at before too. So meta, so basically when we compute validation, it's all in this loop down here. Okay, yeah, that's fine. I just want to make sure she didn't remove this by accident, because this is a completely different decoder, and the full transformer, which takes the output, needs this part. So yeah, then we have like nested if else statements, but this is actually one place where we really need that. Though I'm getting kind of confused about some of this nesting. Okay, yeah, that's fine. So yeah, that looks good. I'll check that off. Nah, that's she's just adding a function. I'm not worried about that. She added a couple losses. Not worried about that. Not worried about that. Explain. Couple else if statements. So yeah, just to give you a summary of what I'm really looking at here is making sure, one, it doesn't break any existing functionality, into that just, yeah, it just makes sense. But primarily I'm concerned about breaking existing functionality, because that's, of course, what I really don't want to do. So, that's fine. That's just the negative log likelihood. Probabilistic. Yeah, she just adds that parameter. Okay, and then she just adds the parameter there. Just more parameter stuff, if statements, else statements. Okay, so I don't think she modified any of that at all. Okay, so that should be good. I'll approve this. Now I should just be able to merge. Okay, so yeah, I just officially approved it. I think, yeah, this could be merged. Okay, so we'll just merge that. So yeah, that's finally merged. That added, I think, a good 60 commits to the repo. So yeah, I will have to rebase probably my own branch in a bit, but I'm not going to worry about that at the moment. Okay, so that's running. Oh yeah, did that include, I think she included the test for, yeah, that did include, I think, the probabilistic test too, which is good. So yeah, hopefully we'll see that. I will just open up weights and biases too, because like I'm interested to see how, I think she told me, but I'm interested to see how some of the probabilistic models are actually plotting. So that should be in here somewhere. Let me see if I can find the probabilistic. I don't know. I probably have to filter. Again, for people unfamiliar, we use weights and biases to monitor all our runs, and even our unit tests actually sometimes log to this repo of weights and biases, just so we know stuff is logging to weights and biases properly. So I'm just gonna try to find inference params dot probabilistic. Okay, equals true. So I'm just gonna see what some of these look like plotted. Okay, so that's the generic test plot. Okay, so yeah, so I think probabilistic was this the upper bound and the lower bound. I don't see the upper bound though. Or maybe, okay, I think like here at least they're directly overlapping, which is kind of weird, but anyways, I think, yeah, altogether that's a good contribution. Which should be good. Oh, looks like our code factor score went up to an A, which is nice. So that's good. I always like to see that. Okay. Let's go back though to our main mission, which was doing this. So yeah, refactoring. So okay, so back to this. I do have a meeting, brief meeting, in about 4 or 5 minutes, so I'll just pause the stream for that. Or yeah, or I could stop and come back, but either way, I'll be back probably at like 4. Yeah, I'll just pause it. I'll be back at like 4:15 now, or something like that. Yeah, or 3:15. Yeah, it's weird. I actually set my stuff on Atlantic time because that way it encourages me to think it's later than it is, which can help. But okay, so yeah, what was I doing? I was fixing these param issues. So okay, so yeah, I was fixing all these issues. So yeah, I was also looking over here and seeing that yeah, seeing what some of these other stuff was, like the sequence number. Oh yeah, they had a main file too, which like was like train set dot sequence number. What the heck is train set? So I'm just seeing what, like, so it looks like train set's another class, and it has its own sequence number. Each one has their own sequence number. I guess sequence self.points.shape. What the heck is points.shape? What? I think they're like saying each sequence needs its own. They're saying that each. Oh wait, sequence. Covariates, points, covariates. But sequence number doesn't change after that, does it? So it's basically static for the time series. I forget if their paper said anything about having a sequence number. Yeah, I'm still not exactly sure what the usefulness of that is. I'm going to... I might try to come back to that in a sec or look at the paper. Sequence number. Sequence length? Or is that window length? Or wait, no. The sub length was what we already talked about here. Was just like the... Actually, I can copy their remark in, I think, their main file. Sub length. Sub length of sparse attention. Oh crap. Wind is bad outside. Sub length and embeddings. I think that's that basically. Yeah, so it's just that embedded dim. Yeah. We'll just actually throw in some of their comments here. Okay, so yeah, it's about time. I have to jump on this meeting quickly. So. Hi.
Is it Isaac?
Yep.
Hi, Isaac. This is Rob calling from Best Buy. How you doing?
I'm good. How are you?
Good. You got your latest Hacktoberfest done?
Yep. Yep.
Great. And did you get a chance to review the position?
Yeah, I looked over the description a bit, so.
Do you recommend it from
Um, not too much, I guess, just in general, like, I saw it was like, yeah, kind of doing operating machine learning initiatives and stuff, was like, just wondering in general, how is machine learning at Best Buy, is it kind of mature, or is it still something new Best Buy is just getting into, or? Yeah, yeah, I have a resume. I can send it over either just on LinkedIn or wherever. So. Okay, that sounds good. Yeah, I'll send that over then. Yeah. Okay, that sounds good. Okay, yep, sure. Thanks, you too. Bye. Okay, so yeah, I'm back. Just had, as I said, a quick call. Um, so, um, okay, so, yeah, I'll just make sure this is back and running. Okay, so yeah, as I was saying, now what I'm going to do is I pushed a couple commits. Okay, yeah, I was just finishing updating and figuring out what all these things were, from the original code. Um, so we have this. So yeah, the only thing, yeah, I'm having trouble figuring out exactly what is and how to pass it in is probably this sequence number. And there's also another thing, I think, series ID. So I think what's going on. Let's go back to their stuff. Is that what's happening is that each of these, it's like wind length. So yeah, is that each of these is essentially getting the number of sequences, total number of sequences based on that window. Is it based on the window length? Yeah, I'm not sure based on this. So window length. I think pred days covariate. So this is the shape. So the series length is essentially, wait, is this series? Let me go back. Transformer bottleneck. Sequence number. Okay, sequence number. That might be different than the series length. But in any case, sequence number, yeah, it becomes off of this points.shape stuff. I'm actually going to go probably back to the original paper, see if it says anything. Sequence. Sequence. Because yeah, I haven't actually seen that done before. Or the other thing we could try is, I guess we could try actually running some of this code to self.points.shape. So it looks like this is then calls this thing called load data. I'm not sure exactly. So which reads this CSV. It looks like covariates, index date, covariates. They do some indexing type stuff, and then it returns this tuple. So yeah, do they give like documentation on this at all? Train set dot. Yeah, because that would be something that like maybe they have a readme. Sequence. So this is their official readme. So yeah, their data is stored in a Google Drive. Okay, so yeah, this is still confusing me exactly what this sequence number is. And I think this is probably a good example of how, like, particularly people could help make your code clearer by kind of explaining what this is. I'm guessing we can look back at the model too and try to see what it's actually using this for. So it looks like there's this sequence number, and based on the sequence number, it's actually creating an embedding dimension. So, but the number of sequences is actually creating some type of n-dimensional kind of embedding. And that seems to be somehow different than input dim. When input, because normally I'd think that like you do something. So let's look at ID. So we do this, they do this ID embedding, which is, I think that, okay, so yeah, and then series ID goes through this embedding dimension. So I think what's happening here is they're warning the they're learning essentially the positional embedding of the series ID. Though I don't know how that's essentially different from the positional. Wait, so it's some type of learned embedding. So we're just gonna actually look through here. We use learnable position embeddings. For covariates, we use all or part of year, month, day of the week, hour, minute of the hour, age, and time series ID. That must be what it is, time series ID. According to the granularities of data sets. Age is the distance to the first observation in that time series. Each of them, except time series ID, only has one dimension and is normalized to have 0 mean and unit variance. Okay, so this is definitely the relevant stuff. Okay. For covariates, following is free, so it's number 3 that age. Okay. So this is essentially some form of positional encoding. And because then I'm guessing they concatenate this or something. Yeah, so basically for then this forms their embedding stuff, and then they concatenate it. So the first thing I'm going to do is I'm actually going to, before I even try to figure out how to make this work with our data loaders and exactly how to do this, so I'm just going to actually document some of this in my code. I'm actually just going to directly copy this. This is like confusing enough. I think it would be useful to have here. So because I know if I come and look at this again in like a week or so, I'm just gonna probably have most of the same questions and stuff. And certainly, I mean, it's like it's gonna get me annoyed about. So, okay, so at least I now realize what those are and stuff. So, line too long. Yeah, well, of course it's too long. Oh, nice. Okay, so, again, come on, line length. Sometimes I wish we could just get rid of line length. Okay, so yeah, so at least now I know that. Just put a link to this too. Oh, oops. Actually, I should probably put this at the top somewhere to show. Oh, oops. I actually don't know the best place for that comment. I think we need 2 though, or Linter will yell at us. Okay, so that's fine. Okay, so I'm gonna quickly commit this. Okay, so at least I know what that is now, so. The question now is just how to actually get that to work with our framework. Okay, so looks like, yeah, this might be actually more complicated than I saw it, because we may actually need some custom data loader for adding this model. We could probably use one of their data loaders even. But yeah, this likely is going to require its own data loader, is my guess. At least in the current state with that. Series ID. So it comes in, yeah, pretty standard dims. Here. So yeah, it does take series ID, which is apparently, I don't know if this is an actual integer ID, or we could actually probably look at the actual data loader. Where is it? Get item, I think it returns series ID and then the scaling factor. So yeah, I didn't realize this actually would probably require its own data loader. I actually thought this would be a relatively simple model, but looking at this, it's definitely the problem is our data loaders at least in their current state don't return stuff like that. So they definitely don't return like they don't even have a concept of series ID. So that's somewhat problematic. The other thing that I was seeing right here is that the length, this is obviously arranged in a very specific way. So again, hour, minute of that, day of the week. We use all or part of year, day of the week. So this is arranged. So I'm not sure these are part of the input dim, which would be my guess. And then it's like organizing it in a specific way. I don't know how that fly got in here, but anyways, so day of the week, input dim, time series ID, etc. So yeah, the question is how to make sure that our data loaders are always returning those in the right way, depending on the data set. And yeah, we can look at their data loaders for an example. I'm also gonna have to probably plug in my computer again. I think it's about out of battery. I'll do that quickly. Okay, so I plugged back in. So yeah, the question now is essentially just yeah, how to do this. So like, probably the easiest thing I think to do is actually, before we do anything, like look through what these data loaders are doing and then try to figure it out. So yeah, this obviously isn't ideal. Like, I would like to just be able to throw it into our stuff, but I think, yeah, we have to try to figure out exactly yeah, what's going on with the what the heck was what's going on with the series. So what we can do is we can probably just for now look at okay, so we can I don't know what the best way. Maybe it's probably better to get the data set to yeah, to just to try to actually maybe run the data loader on the data set and see what it's doing. Yeah, because this is definitely an area. I mean, it's not like awful code or anything. It's just hard to tell what it's doing without actually running it. So yeah, what we could do is we could. Oh, so this data set preprocessing is based on deep AR. So yeah, anyways, I think that's how they base their stuff. So yeah, I guess deep AR does a similar thing actually, which is interesting because we actually haven't been using like a time series ID at all when processing our stuff. But yeah, I do think the best way forward with this is probably to maybe even just take this code and then try running it and then even add some print debugging and then figure out exactly what the dimensions are in the shapes of the time series stuff the data loader is returning, and then based on that we could either add a data loader that you could use to flow forecast, or we could modify our existing data loader so it could take, say, a parameter and be able to return the series ID. So yeah, I'm gonna go do that quickly. So yeah, I'm gonna just probably maybe even spin up something like a collab and then try to add this code to it. And just see well, first of all, I can see if the code even runs, but then also to just really try to get a better sense of yeah, this model. So yeah, so what we can do is, you don't even need to take the whole code. We could just, probably copy, I think, what's a good one? We could use, what's this this L data set, I think it's some electricity data set or something. And there's there's different functions here. So this is an example of one of their dataset classes. So we could probably just grab all this and then paste it in. And yeah, I know this isn't a very elegant way of doing things, but sometimes it's honestly what you have to do to understand, particularly code that doesn't have that much detail to it. And so yeah, because we really need to, before adding this to our stuff, we really need to understand what this indexing is doing. So and then we just need to download the electricity thing, right? I think. Oh wait, where was my folder with that? Oh, oops! Did I lose my folder? Oh wait, I can just go here, right? I had that .sh or something. Should have been like the traffic stuff. I think there's like, is this? Oh wait, no, we're doing electricity now, right? Yeah. Oh wait, what's this LESH7J? Does he do a different one for each? I think they could work with either one, right? So yeah, we just need to find the path of this. Path is just data / electricity. I think like in the paper they said, or somewhere in their code they said like Google Drive or something. Oh wait, that was in their README, right? So let's do this. I forgot how to actually the best way to get something from Google Colab. There's like an art to it, right? Yeah, there's definitely something you can do. We got Google Drive. There's definitely a way to get from it, I think. That's what I think, at least. So you can do like curl. Oh wait, do they have to make it public? I don't know. I remember there definitely was a way to get something. I don't know, it's probably not worth the pain of like looking at. I'm just gonna download the shit and then upload it. 304 megabytes. I honestly don't like storing stuff on Google Drive. For me, I'd always then store it like in a GCP bucket instead. It's so much easier. And I mean, like, yeah, the cost for storing something in a GCP bucket is like probably not even that. Isn't honestly even that bad. It's like very small. Okay. So, I think you even get some free storage on it. Wow, this is 711 megabytes. Wow. Okay, so I'm gonna minimize this. I was honestly not envisioning this digression. Like, I thought this would be simple and we'd be writing the unit test by now for it. But, okay, so we can now, I think, just call this. So this should be pretty simple. Let's call this. Or yeah, we'll just initialize it there and then call it next line. So LE blah blah blah. What is this? This should be electricity dot text. Train ins num. I have no idea what that is. That actually worked. I guess all those imports actually worked. Surprising. Train ins num pred days overlap. Let's just use whatever settings they have here. Input size, partition, early stop. No. What are those parameters? That's what I'm wondering. Okay, I'm not sure. Okay. I'm gonna probably have to look at the main file again. Train ins numbers, maybe like 10. I don't know. Just put some. Fred days 7 overlap, maybe like 2. Window length. Train ins nums. Maybe it's in here. Args. So there's actually an arg for that. Where the heck are the args? Because I have no idea what that means. Wait, where's in the parser? I thought it would have to be in the parser, right? What? But I didn't think I saw that in here. What? How could that even work? I would think it would have to be in here somewhere. This is more complicated than I thought it would be. What the heck? Where do they supply this? No idea where they fucking supply this thing. No, wait. Was there another SH file? Maybe there was like, I don't know. That's really weird. It's like you wouldn't think. It's not in here either. Okay, wait, no, I'm going back in that file. But yeah, how can it not be a parse argument anyways? args.path.args. args.path. Oh wait, there it is. Oh, it was probably because of that. Number of train instances. What the heck? Number of train instances. Train instances of what? So that's just instances here. I guess that's what it is. Train ins nums. I'm still not actually sure, but that's one of the reasons we're playing around with this. So let's see if this works. We'll just call it like E or something. Withhold length? What the heck's the withhold length? I certainly hope, like, if someone goes for R code at some point, our indexing is not this hard to figure out. I don't think it actually is, so. Okay, so. Wait, it uses a random seed. What does it actually use the? Oh yeah, that's the numpy random seed. Series length. Okay, so I wanted to figure out what that like seek num. So what the heck's seek num? That's my first question. Like, what's the value of this? 370. So how is that computed? So why is it 370? That's my second question. So that might be like the total number of sequences, I think, in the... My guess is that's the total number of sequences and stuff. Though... Yeah, that doesn't really make sense, actually. Because if it's only 370, so... Covariate num... Okay, so this looks like a date that they're starting training on. Wait, so what was seqnum? Seqnum's this point shape 1. So wait, what's self.points? That's a good question too. It's like I have no idea what this is. We can print the shape. That's probably more useful. It's 11,040 by 370. 11,040 by 370. Wait, what is points in general? So it looks like points is going to be basically from the beginning. Wait, I mean, by my guess, it looks like points is essentially just the beginning to the end of this, right? I mean, like points is essentially like the input dim, though, right? Because like, God, this is, oh shit, I didn't put the right thing in. Because to me, that like essentially points looks like it's just the df dot, like, of course this is gonna like take forever. So data dot it looks like, oh oops, that was stupid. Wait, 6,009 and 11. Wait, what? What the heck is what they do here? Data equals data dot resample. Huh? What the freak does that do? I gotta look that up. Do you have an example? I'm surprised I haven't used this actually. PD.series range. Downsample the size into 3-minute bins and sum the values of the time steps falling into a bin. Okay. So it looks like they're doing some transformation to change the temporality of the data. So they're going down to like maybe an hourly level when the initial data was at like a much higher level, is my guess. Because like maybe if we do like something like data.head. So yeah, so 370, which is this, is definitely the like input dimension, right? So I'm still not seeing how like that's different than that. Like if we go back here, shouldn't seqnum be essentially the input dim? I don't get why they're supplying 2 parameters. Because I'd think that, or maybe the input dim. Maybe they're assuming, though, that they're not actually passing all those columns. Though I don't get why they'd include them then. Okay, let's look at what this thing, what this thing actually returns. So it looks like, yeah, we could look at like what this thing actually returns. Points, codes, variance, withhold. So points, okay. So it looks like it's a forcing tuple. I'm curious which, if we look for the code, I'm curious of which of these is actually then passed to like X and stuff. Because it looks like the data loader returns like 4 things and then passes, but we're only passing 2 things to the actual model. We're only passing like 2 things to the actual models. So let's look. Where the heck's the model, first of all? I'm gonna try to find the model. You know, we of course can't have something just called model. Oh, it's probably just called like encoder, right? Mu sigma. Okay, so yeah, so they where do they call data loader? For step data and enumerate train loader. So data probably is actually this. My guess is step data. Encoder.train. So step data and enumerate train loader. Data. Okay, so yeah, so this is the data is essentially those 4 things. So training sequence is essentially just points, as we know from here. So let's look at this. Let's just do e dot like 0 or something. Let's see what points is. Points, what's points dot shape? Oh, so it isn't, that's definitely not 370. 5? How'd that get from 370 to 5? Maybe that's what we do when we do. Wait, what? Why is it 5? Train ins number. Wait, how did it get to 5? Because yeah, in the window length is basically our, now I know is basically our sequence length. So at least we know that now, right? I mean, but what I don't know is how we get from 370 dimensions to 5 and why. Yeah, so yeah, window length definitely is what we would call forecast history. We know that for sure. So we can remove this question mark. And we can finally call it something else. And this is also definitely an int. And then what I don't know is why that goes in there, so that's what our next goal is to figure out, is how the heck that goes down to. Ugh, come on, can you stop bitching about line length? I hate it complaining about line length. If it's not going off the screen, the line isn't too, isn't too long, you know? If it goes off the screen, yeah, it's not too long. Okay. Okay, so what we still don't know is like how, or at least I don't know, maybe if someone smarter than me already figured out why this is 370 dimensions and why it's suddenly going down to 5 dimensions when we get this. So they just like, do they just want to split it up into sequences of 5 or something? I don't see any 5 here. So I have no idea why it's going down to like 5. So, train seek. Some of the indexing stuff I hate, but it's okay. What the heck's this? Or is that covariates, or what the heck's covariates like here? Oh, do they split? This might be similar to DAR and N. They might split up the like target. Though no, I still don't know why I would have a dim of 5 though. But we could check the dim of covariates. Maybe covariates is where they like, where the stuff is, you know. The other like, oh no, I guess not. Let's just check all of these. Dates. Withhold one. Yeah, I don't understand basically any of that. Covariates. So I have no idea, like, why would this be 5? That shape makes no sense to me. Yeah, we could yeah, we could go back to some of this stuff. Wait, what? Okay, so why is this 5? It just makes no sense to me. So okay, we need to figure out. Wait, this is 5 though. Like if you look at this, this is 5 rows. Oh wait, no, that's just because we wrote head. That would never be 5. Never mind, that was stupid. 6,000. Okay, yeah. So I don't know why that is. So we would normally here do get index, or wait. Get index. Let's see this. Get index. Okay. Yeah, I'll just look at it here. So we do this thing called get index, which is self index. Yeah, that's pretty standard. T window length. Oh wait, that's the scaling factor, right? Yeah, so points. So points basically they do from series index. Series ID. What the heck's series ID? Okay, I need to look just at the R data loader. There's series ID stuff. Okay, so when it goes to get the item, self.sample index. Self.sample index. So Okay, so here is where it goes through this like thing where it runs through a bunch of stuff. Anyways, it returns basically some based on this key. Points.size equals covariate number plus 1. Okay. Okay, so that's where it gets that size from. The question is why. You can look at the different things too, like covariate num. Okay, maybe it's time to look back at the paper and see if they say anything about this. That are assumed to be known over the entire time period. Oh, I think they're just picking like a random number of like covariates to like choose, right? To fully utilize both the observations and covariates, we concatenate them to an odd matrix. Okay, I keep forgetting I'm not in that browser. Okay, so sequence number. So let's recap. So somehow, or for some reason, they're reducing the number of covariates to say only like 5, but then they have something called like sequence number, which is this really big embedding thing that would be like something like dimension 370. Yeah, that would be like dimension 370, so. Which is kind of the overall length. And then that becomes a layer in the network. Yeah, it doesn't make much sense to me either. Here's the paper. So wait, I need to look at that layer. What it's doing. So the layer, the sequence number layer. Okay, series ID. So wait, did the downloader return? I assume it returns series ID somewhere, right? Or wait, where's it get series ID actually? This should be interesting. Series ID. Wait, the search thing they're calling series ID. So wait, so dates is series ID? What? Did I miss that? So dates is the series ID. Wait, what's dates? Okay, so that's, yeah. Cal covariates. Okay, so... Oh, so these are just, like, the different, like, covariates they're doing. Month, weekday, hour, right? Ha ha ha. So, 4, 5, so 3, 4. So wait, is that actually just the dates, like, in points? Could be. Or wait, where's do data dot head? Let's just see this. I don't know why they're choosing to make that 370 though. Okay, I'm gonna take a few second break, then we'll be back. Okay, I'm back. So yeah, I was saying I still don't really understand why the heck they're just embedding this to 370, which doesn't seem to actually be relevant at all, because they're not passing anything like that. What was that covariates and stuff anyways? Covariates. These are the covariates. What's the shape of this? It's just 10. Wait, so covariates then becomes, I think, like series ID, right? Or wait, series. It's the third thing that becomes series ID. Never mind. Series ID. So points, covariates, dates. So dates becomes the series ID. Yeah, that's right. What happens to covariates here? So covariates is called something called GT. I have no idea what GT does then. Oh, GT. Oh, yeah. That's the weird thing. GT is like. Wait, I think GT is like. Okay, that's odd. GT goes into the loss or. Loss criterion. Oh, wait. GT is then part of the Gaussian loss. Oh yeah, this is part of their confusing loss function that I was going to get to later. Yeah, this loss is like really weird, but loss equals criterion GT. And so this is what GT is. So GT is essentially the covariates or so criterion. Wait, what's coming out of the encoder though? Mu and sigma are coming out of the. Oh yeah, that's right. Mu and sigma come out of the encoder. And then this like loss function takes mu and sigma, and then mu and sigma, and then GT is. What is GT? Wait, what was the loss function again? It's the Gaussian loss, right? I think, yeah. The negative log likelihood of Gaussian distribution. So GT is essentially just something from the data set, it appears. Then it's returned and stuff. So that's kind of interesting, I guess, though. Okay, so the model. Okay, yeah, so that reinforces the notion we'll probably definitely need some kind of custom data loader for this. So yeah, GT. Covariates dot shape. But yeah, my question is for the covariates. Since that's the actual stuff, it appears. Train seek. Wait, what is covariates? get its age feature. Okay, this is getting too confusing. Standardize. Okay, yeah, this is going kind of way out of the scope of what I was originally thinking I would do. So yeah, I don't know what's best to do now. Because yeah, this thing is very confusing in what this is doing. And what it's returning. Because yeah, the loss function is even kind of weird because it looks like mu and sigma come from what the actual model output is, and then what happens is, where's that? Mu and sigma come from the actual model output. Those are used to instantiate the Gaussian loss. And then basically it does like, it then throws in the whatever this covariate GT stuff is, and stuff, and then uses that which is from the actual data set apparently. It would be helpful if we had some, like less like important data maybe. It's also unclear like which columns it's actually using. So is it using like, I know it's not using all of them obviously, but is it just like indexing? Did they talk about their Gaussian loss? They don't talk about their training loss though. So yeah, I just pushed what I have so far to the repository. I think, yeah, I'm kind of confused by this. So yeah, I'm gonna check out kind of more in a bit, I think. Because yeah, I don't really know what's yeah, so I mean, I understand some of this, but some of this is really confusing, like with the Gaussian loss and the scaling factor and that sort of stuff. Actually, maybe it would be good to try to run this whole thing though. I don't know. To try to run the full thing and then see what's going on. Cause yeah, the covariate. The covariates are very confusing, what they're calling like I think maybe they said they got the code from Deep AR and PyTorch. So maybe they have more explanation for some of what that like covariate stuff is. Weighted sampler. No, that's not it. Okay, wait, they said they got these from... Let me see. I'm gonna see if I can find some documentation on these. Okay, oh, it's based on deep AR predators overlap. Yeah, I don't know like a good way to make sense of all this. So it looks like, as I said, what they're doing is we basically go into this. They like they resample into hourly intervals. This is train end equals train end plus 20 free equals. So this is just the like start of their different things. Points, as we saw, is basically essentially now they're just indexing training data, it looks like, or indexing. So yeah, they're just converting to NumPy array. But here's where it starts to get confusing. So the sequence number is total number of time series in DF. And then what they have is the data length is then total. I think this is the total length of the DF. The number of hours, D hours. So yeah, pred length is then going to equal pred days times days hours. That makes sense. Withhold length is going to equal the pred length. Okay. So covariates is going to equal covariate num. What's covariate num? What the heck? So yeah, the first thing is to like, what is covariate num? So it looks like just here, like covariate num is like 4 or something. Okay, so yeah, again, they're saying they're using only 4. And then yeah, point size is just and when they're slicing, train sequence is going to just be the window length and point size, and then they're reassigning to that basically these points -1 series index -1. Okay, what was series index? No. Series index. Oh, maybe they're trying to train the whole model at like the same time and stuff, though. That could be something. Based on the time series index, in which case we don't actually need that. That could possibly be that. Because like they might just be iterating across like all the dimensions, is my thought. Yeah, so actually I think series indexes, they're doing something like they're iterating across all the different dimensions and stuff. And so they're really just like iterating across. So yeah, so actually I don't think we really need the series index in ours unless we think we'll have a very wide like horizontal data frame where we'll like want to sequentially iterate over each series, or use that. So that's kind of not what we. I don't think we actually need that, at least not right now, is going to be one of my takeaways from this. We still need to figure out what the covariate stuff is. So I think the target, what they're returning for the target of essentially the loss. So as I said here, so I think as I said the second thing. So yeah, that's surprising because they have something called. Oh wait, here it's called GT. Or wait, maybe I got that wrong. Yeah, GT series index, series ID. Wait, is this different than what I was playing around with? I'm gonna go back here and see. Wait, no, that's a load data, never mind. So yeah, so GT. Okay, yeah. So yeah, that makes sense because like here you'd have series index. GT is points, series index. Series index. Okay, so yeah, series ID and series index. So series index. Okay, let's just check something. Points that shape. 10.5. So that's the window length, and then GT. Oh wait, so. Wait, what? How was I assigning this? Oh wait, I should change that to what it actually is. I'm just gonna change that real quick. I hate this stuff is confusing though. Like, and I hope like people. Well, I mean, like it's obviously a research paper, but yeah, this definitely could have been like a little clearer what was going on because. This is a lot to look into. So, GT shape, yeah, it's gonna be 10. Train shape. What about train? $10.5. Okay, so is it saying predict essentially the next 10 steps? Or do we specify that as a parameter? Pred days. I would have thought pred days. What's pred days? I have no idea what that is. Because like, if it was the like number of days you're predicting, then shouldn't that be equal to? Train start, trains end. Covariant number is 4. Okay, wait, let me look at how GT's like gone again. GT, so GT is the points, it's the series index. Yeah, I guess. Let me print series index actually. I want to see what series index looks like. Or wait, what's San? Oh yeah, this is just a dict, I think. But yeah, I want to see what like series index is. Because that's what they do points from, right? Yeah. Points and GT, right? Oh, God. wait, T series index through series. Wait, but T is like 5, right? No, T's window length. Okay, yeah, that makes sense then. Okay, so yeah, that makes sense. They basically go ahead. Those are just the actual target, and the weird thing here is they're just passing the target in as almost the X parameter in the loss function, which you normally wouldn't think you do. Apparently they do it. So okay, going down, that now finally makes sense. So then the question is essentially, well, we haven't done a lot of actual coding. We've mainly been looking through this person's code. Yeah, it hasn't been much of a live coding session. Just been me trying to understand this code. But yeah, I think that's the thing with, well, actually a lot of areas too. A lot of like development actually isn't necessarily actually developing. You're often just trying to understand other stuff what's doing. And in machine learning, I think that's definitely true because you have all these things that are passed around, and if code isn't well, documented, you just have no clue. So finally I understand that. I don't think we actually need the series ID. As I was saying, I'm gonna put like something like a question mark, not needed, or something. Because like we're never iterating, I feel like, across the different series, and I'm guessing that's why they're doing this, because they're like trying to iterate across the different like series or something, and get like a series ID. Series ID. Have we determined this determines series ID? Yeah, so I feel like they're basically essentially moving like almost horizontally across the different series IDs and stuff. So I don't think we actually need that. So for now, what I'm going to do is I'm actually going to make this optional. Well, sequence number I'm going to make optional. And I think I might just get rid of this layer, this ID embedding. We'd obviously keep probably the positional embedding, I think. And then, torch.tensor, torch.arrange. Length, okay. So yeah, I'm guessing they're getting that stuff through that, and then they just do POID and shit. Yeah. So yeah, I'm going to like. So actually, I might keep this in case we later do like some really weird horizontal stuff, but in general, I'm just going to probably, though of course now I'm just going to probably yell at me for a long line, but I'm going to do like, okay. So yeah, I'm just going to do if sequence num. Finally, I'm actually coding something again. we'll just do that. That's what we'll do. So yeah, that's the big stuff. We've got the big stuff worked out, I think. So okay. So yeah. Oops. I don't want to open that. Okay, so let's see. Yeah, I think I might be ending this a bit early tonight too, because I need to get some other stuff done. But yeah, I'll go on a bit longer, like probably 16 minutes. And then yeah, I might come back tonight or do another live stream tomorrow. But tomorrow will probably be, well, no, tomorrow we might do like a similar time, like 2 to 5 Eastern time. Okay, so yeah, that's what I was gonna do. So is not none. Okay, so series ID transformer. Oh wait, is transformer? That's just what we saw above. Mu self dot mu sigma mu. Yeah, that's right. Also, if I get rid of series ID, it's gonna greatly decrease the complexity of like doing training loop stuff, because I don't really want to modify training loop again. So yeah, I think I'm just gonna get rid of it. Though I mean, yeah, I obviously don't know if that's like the best idea. So the only question left then is like still is then like how to it's like the exact shape of like points for then creating that like embedding layer. So we actually did have points here. So it looks like for that, like when they're doing that stuff, we actually have this. Position. So yeah, so they do like, it looks like they take the length. Yeah, the length dimension, which makes sense. Arrange length. Torch dot arrange. Wait, when you do that, that actually creates that. I'm confused. I'm gonna play around in Torch for a sec. So like if I create a variable in Torch.rand, let's just pretend we're doing like an actual thing. We'd have something like batch size 2, sequence length would be something like 10, which would be our forecast history rather would be 10. And then our number of like say feature time series might be like 4 or something. Oh, I never actually imported Torch. Import Torch. Okay, so r.size 1. Yeah, that's what I saw, is that would just like, or if we do that like so we do length equals r.size 1. So yeah, that just creates 10, right? So yeah. So that's just 10, but they're saying like, they're saying that they're going to create something. Are they creating a tensor? Yeah, they're creating a tensor. Let's think of this length. Yeah, see, I'd think you'd be doing like clone or something. Or wait, they're just creating something that's like 0, 1, 2, 3. Oh, so that's just like creating like 0, 1, 2, 3. is essentially a tensor. Okay, that makes more sense. So they're just creating like kind of a new tensor and then saying, oh, you should learn that. Oh, then I get it. And then the other covariates like weekday, month, and that other shit is like then what they're actually using for the other dims, since they're not selecting any stuff vertically across the time series. Okay, so that actually kind of makes sense now. So yeah, so okay, wait. So covariates. So get item, the train seek is going to be these free, and then the actual thing is going to be point size equals covariate num. Covariate. What is the covariate num? The covariate num is those free. GT, okay. Maybe that stands for ground truth. Maybe that's why they called it GT. Though I still don't like it because it's really confusing. So yeah, then this is just the series ID, which makes sense. That makes pretty much sense. Self.covariates, series ID, series index, self-win length. Okay, so covariates. But covariates, it looks like, was only, like, free. Whereas this is 5, right? Okay, well, what's points look like again? Points. Points is 5D, right? Yeah. Yeah, it's like something like 5. 10 to 5. So one would be that, but what's the other thing? It's like, that's free. Oh yeah, we're gonna look at series index because I think series index is the actual like is another feature they're using. Oh yeah, that's probably that thing that like they were calling A or something. Yeah, so that's like that age thing. Yeah, that's the age. Okay. You can probably calculate that. Yeah, we can probably do something with that at least. And then they just essentially... Okay, yeah, that's beginning to make more sense. Okay, that sounds good. So yeah, so I finally figured most of this out, I think. So, okay. So I do need to, though, I would need to supply to forward. Well, I mean, I don't necessarily have to, but if I was going to replicate their stuff, I would supply that to the A part. But yeah, we could add that later. So, okay, that's good. Okay, so that's all those main ones, and then yeah, that's all we need. So yeah, this should be actually semi good. I just need to make sure the parameters I'm passing are right. Yeah, as I said, for now, I'm not going to deal with this. I'll probably do this maybe later, maybe never. Because, yeah, ours doesn't really have a bunch of those different horizontal ones. Or at least the most of our, like, framework isn't really set up to do that at the moment. But yeah, as I said, the idea that just they have a lot of different like time series, and they just want to iterate across all of them like horizontally across the data frame, if you can imagine forecasting each. So those are the main things. I do have to figure out how I do this Gaussian loss. First of all, I'd probably remove the loss from here so it wouldn't be like down to here, and stuff. And then, but then the other thing I do is oh yeah, I gotta get rid of the stupid series ID for now. I probably just like throw series ID as like none here. I just like do X first, and then like series ID is going to be like none. And then we could just like do like if series ID, is none, then we just don't do it. Or we could even do self dot series ID or something. Okay, so that's the major stuff. And yeah, that should be good actually, so I hope. So, oh wait, yeah, the problem though is that now we have this. What we could do instead is, instead of having that there, probably, yeah, I don't know. I might just get rid of this. Just gonna get rid of that part. Now it's gonna wonder why this is relevant. Yeah, the linter is then gonna be pissed if it's not. I don't know. I'll just comment this out for a while. Though it might now be like, why are you passing series ID? As a linting problem then. Okay, wait, I will do that then, actually. Because it's not worth doing this shit with the linter. And the linter is then gonna, like, complain about stupid stuff. When I might, still want to add it later for historical purposes. So... Oh wait, no, come on. Now it's getting all stupid. But yeah, the series ID should actually be there. And then we should just do... Oh, come on. Okay, so that's fine. hope that would work, but I don't care because I'm not going to really run that either. Okay, finally, yeah, we finally got that stupid stuff. So, oh, the last one failed for some reason. Maybe we should look at it before we commit again. It's almost, what is it? It's almost 5. Still have to, like, go for a run and stuff. Okay. So, yeah, we open the peep what is it? It's like transformer bottle, or bottleneck. Transformer bottleneck. It's 50. Oh, yeah, of course it's 59, because we merged Corty's thing, but... Oh, wait, so that's fine. Yeah, we don't care about code cove right now. Okay, so we'll add this. And what we could actually do is we could just basically... Oh, yeah, we could start by actually adding... Maybe we could actually add a thing. Wait, we have Gaussian loss somewhere else. I just need to make sure. It's... I think we already have Gaussian loss in our loss functions, but I'm not 100% sure. Where... I should be able to get it here, right? Yeah, so... Yeah, sometimes a while ago it's like we should move all of our loss functions out of custom op because it makes them move. But yeah, which we probably should. Mape. Okay, yeah. Yeah, I think that's basically that's what we had before, right? Loss normal. Or wait, is it? Is that what it is? What's this T-disk though? Oh wait, that might just be like, yeah, we just... Okay, yeah, that's the exact same thing. Yeah, so that's good. We have quantile loss. Okay, so finally, so I have to think about how this will actually work. So it's kind of a weird training loop setup. We'd normally iterate x, y, mu, sigma. Okay, so the Gaussian loss, we probably have to modify trainer anyways, so to use that loss function. But actually, technically I think this model could work without this loss function. It might not work well, but it should be able to like train even if it doesn't have that special loss function, probably. Or wait, I need to look at main again. So you do mu, sigma encoder, you do unsqueeze. So you do blah, 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 loss backwards, loss item, encoder. Why is it called encoder? Like, where do we use the decoder? Or do you not use the decoder? Encoder. What is encoder? Is the encoder really just the encoder? Probably is, right? Encoder. Like, why would... I still don't know why you'd call, like, when it's the decoder transformer, it just call it encoder. That doesn't really make sense to me, because that's bound to confuse me. Like, it almost just confused me. But yeah, we should be able to actually throw up a file, so yeah, let's do that right now. So yeah, so as I said before, we are a test-driven repo. All new models do require at least one integration test to show that they run. So in this case, I'm going to be taking, I'm going to be creating a new file to test that this runs, and that's good. In theory, we should actually probably really have some unit tests because we're passing around a lot of parameters. So it would be really good to make sure things are actually initialized the way they're supposed to. I might add those later. For now, I'm just going to go right to an integration kind of test to make sure this model runs. Usually the bare minimum, though, is the integration test. I might, if it's really complicated, I might say add unit test, and it's probably a good idea. But a lot of people probably don't want to add like a unit test for this. Actually, before we even add the unit test, we could just throw this in our notebook and just see, like, make sure all the parameters are getting passed right. I don't want to run the CI/CD without it being passed right. So, did that run okay? I think that ran okay. So yeah, we'll just try initializing it. So let's say we want to run our model. So we do decoder transformer. Oh wait, there's still that stupid args crap. I saw I got rid of all that. Okay, wait, no, args got rid of. Okay, good. So args is done. Haha, I can just get rid of this. So, okay, so it's missing 11 required positional arguments. So n time series, let's just say for now we'd have something like 3. N heads, we probably have 8. That's pretty standard. Sequence number. Oh wait, I saw I got rid of that. Sequence number. Oh yeah, I was gonna get rid of that, right? I saw I got rid of it. Oh wait, no, I got rid of it in the upper stupid scene. I didn't get rid of it in the lower scene. Oh, I should probably. Oh my god. So yeah, that's a good catch right there. So yeah, sequence number should be like a none value now. So we'll have to go back here and embed this as an int now, I'm sure of. Sequence. Yeah, we'll throw sequence number up there in case. Or wait, no. We're gonna do it down here. But we'll leave like this up here. I don't think that's over line length. That should be good. Oh, come on. Under indented. Trailing white space. Oh, fuck, that's too long. Are you fucking kidding me? Fucking shit. Now it's gonna probably complain about this line being too long. Oh, come on. It doesn't need to be indent. What? You said 1 is over, that's under. Wait, that makes no sense. Okay. Oh yeah. Fuck, come on, get rid of it. That's gonna look kind of weird, but at least it's okay with the winter now. Oh god. So let's try this again. We can just throw it here, because like, let's try that, and then try sub length. So what did they say sub length should be? Actually, some of these we should probably add default args so that we don't have to like worry about passing all this shit all the time. I don't know. Like, who knows? Okay, so yeah, okay. So basically, yeah, I'm just trying to find the stuff for sub-length. Oh god. This has been a pretty intense session. Just a lot of reading of code and other stuff. Sub-length. But finally we're getting to the actual model part, which is nice, right? Sub-length, log mask. Okay, sub-length. He had a default value, right? Somewhere. Default, oh, it's just 1. So yeah, I will throw that in probably in my action. Oh god, then I have to throw my parameters around though, right? Because it's like there. Oh wait, I was going to fix that too, so it wasn't window length. So this should be forecast history. Wait. Yeah, forecast history, and this should be an int, and this should be forecast history. Okay. So sublength, we could just do equals 1, but then it will yell at us about doing a non-default parameter after some other shit, so, there we go. Sublength, so yeah, here I'll likewise just be like sublength equals 1, or yeah, it doesn't like, not even regular Python doesn't like it when you do like an optional param. Okay, so sublength, let's just do this, we'll yell about it. Num layers, number of layers. Okay, number of layers, we could say like 2. And embed, what's n embed? What's a good one? Yeah, we'll just use whatever params they're doing for now. And then like when if you see my sweep config videos, which I actually have a lot of them, we'd essentially just like do. So yeah, we could say 20 there. We could do, yeah, that's where we do our big hyperparameter sweep. Forecast history, we'll say 10. Dropout, we'll just say 0.1 or something. QN, what is QN? QN. Okay, so that I think should be 1. Yeah, I'm not gonna move it now. I'll just put 1 here. Scale attention. So that should be false. Additional params, this is our dict. So additional params, what do we need to put in additional params? Oh, that's the additional things for attention, right? Oh yeah, sparse, you could do oh wait, yeah, we don't need those, right? Ha 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 ha. So yeah, we could just put an empty dict there. Dropout probably has to be between, but got 10. Oh, did I mess up the order of this? What? Between 1, so it's obviously one of our params is out of whack. So this says it's actually okay. It's probably where this is passing to this that I messed up or something. So this is end time. So this is why I was saying before, just this small stuff can really screw you later, if you're not careful. So it's basically window length, end time series, N head, sequence. Oh. Did I not remove this? Okay. Oh shit! God. Never mind. That. Okay. I have to go check on something. A wind actually blew over one of the structures outside my place, so I'm just gonna pause for that. A sec. Be back. Okay. Okay, so yeah, I'm back. So yeah, okay, so yep, got back. I think I'm pretty much wrapping up for today, anyways. Well, no, until tonight. I'll actually come back with an evening session. So yeah, I'll just yeah. So that will be it for now. I have a couple things to do. Yeah. So yeah, I have to go take care of something. So, but yeah, I'll be back. Oh, I can get off that screen. So yeah, I'll come back with that, and then yeah, we'll finish up adding the model and committing it. So that'll be all for now, though. So.